Welcome, electric potential. Now, remember that electric potential is defined as the work done in carrying a unit positive charge from one point to another. Now, under this channel, I want to talk about different calculations involving this electric potential. Now, from the board, I just introduced it. Now, you can see that I said the electric potential is the work done in moving a positive charge or a unit charge from one point to another. Now, from equation 1, you can see this is the electric potential. Let's say it's between 2 points, A and B. So, if it's the electric potential between 2 points, I said is the work done over charge. And you can see here I differentiated it. I said this is work done. This is what? Test charge. Now, electric potential can also be defined as the change in electric potential all over the unit charge. Now, this change in U is change in electric potential. You can see where I wrote it. Now, the reason why I'm wasting time to explain this formula to you is during the course of this topic, I will be solving different calculations, electric potential from 1 point, electric potential from 2 points, electric potential from 3 points, charges. So if you do not understand this simple thing I'm doing, if you don't know about this topic, you may find it difficult. Now, the electric potential at a point, look at it, we're talking about a point, a single point. This is the formula for it. When we were talking about 1 point. Now, it can be the electric potential at point A. You can see this is the formula. The electric potential at point B, when we are dealing with only one single point, this is the formula. Now, the electric potential between 2 points. Remember I said we will do between 1 point, between 2 points, between 3 points, between 4 points. So let's go. Let's continue. The electric potential between 2 points, this is the formula for it. Now let's go to calculation proper. Question number 1. If the potential difference between 2 points is 42 volts, find the work done by external agents in carrying charge. We have the charge, the Q0, to be this 5.0 times 10 to the power minus 5, and between the point at constant speed. Now remember from the introduction, we said that the electric potential between 2 points, we said VB to VA, we said is the work done from A to B all over the test charge. Now, from the question, we are to find the work done. So all you need to do here is just cross multiply. So this is all over 1. You cross multiply, and this will give you the work done from A to B is equals to the potential difference between 2 points, right, times the charge. Now, from the question, the potential difference is just 42 volts times the charge, which is 5.0 times 10 to the power 5. And this should give you 21.0 times 10 to the power minus 4. Remember, what we are calculating is the work done. So the SI unit is in joules. Electric potential difference between two discharge points during a thunderstorm in Choba is 1.2 times 10 to the power 9 volts. What is the electric potential energy change of an electron that moves between the two discharge points? Now remember, I said you're talking about 2 points. So we are dealing with the electric potential between 2 points, and we're also dealing with the change in the potential energy. Now remember that the electric potential between 2 points is change in U all over Q0. Now, what they want us to calculate is the change in U. So, by cross multiplication, the change in U is Q0 times the electric potential between 2 points. In U is equals to this. Now, in the question, they gave you the electric potential to be this. Now, remember in this question, they did not give us the charge here, but it's already been given because we're talking about the charge of an electron. So the charge of an electron, look at it, the potential energy change of an electron. So they are talking about the charge of what? An electron. So this will just be 1.6 times 10 to the power of minus 19 times 1.2 times 10 to the power of 9. Remember, the charge of an electron is this. It's a constant. Now, this will give you 1.29 times 10 raised to the power of 10. Now, please, what is the SI unit of that question? Of course, this is changing the energy. So you get 1.29 times 10 raised to the power of 10, and the SI unit is in joules. This is question number 3. What value of PD, the potential difference, will be required to give a helium nucleus? The charge is 3.2 times 10 to the power of minus 19 coulombs. The kinetic energy is 48 times 10 to the power of 3 electron volts. This is electron volts. Now, remember, still the same formula. From 2 points, you have the change in U all over the charge. What is the value of the PD? Now, remember, this question is okay, but this is electron volts. Now, whenever you have electron volt, you have to times it by 1 times 10 raised to the power of minus 6. So, this is 48 times 1.6 times 10 raised to the power of minus 19 because of the electron volts. Now, if you calculate this in your calculator, what you should get as your answer is 7.68 times 10 raised to the power of minus 15 joules. Now, remember, in physics, when two quantities have the same SI unit, they are the same. The kinetic energy is measured in joules. Potential energy, the potential energy here, the change in U here, the change in potential energy here is also measured in joules. So you can see in this question, they did not name this change in potential energy, but because of the SI unit, they are the same. So this is just 7.68 times 10 raised to the power of minus 15 divided by the charge, which is 3.2 times 10 raised to the power of minus 19. And 2.4 times 10 raised to the power of 4 volts. Times 10 raised to the power of 4 volts. This is the part 1 of the video. The part 2 of the video and the part 3 of the video, I'll be talking about how to calculate the electric potential in 3 phase, in 4 phase, between 4-point charges. Thank you very much.